I'm super scared of thunderstorms, and I'm super scared of tornadoes especially. So while researching fractals for a classroom assignment, I noticed how they are used in meteorology. I then decided to use Chaos Pro 4.0, which I downloaded from chaospro.de, to demonstrate and execute the experiment. I wanted to see if altering the variables in the equation for the Mandel fractal will change the outcome compared to the original. This will then demonstrate how meteorologists manipulate fractals to show and predict weather. In the experiment, like I said, I used Chaos Pro, and this is the original Mandel fractal. And each time I altered the variable by 25%, the variable which is critical point in the equation, and each time went down by, or added 25%. I increased it, and as you can tell, this is the third fractal. It's starting to burst out through the left end, through the left. And as it keeps getting higher, the critical point keeps getting higher, it keeps getting smaller. And I'll show you the graph in just a second, where it shows how the calculation time actually gets smaller also. Here's the calculation times. Now the critical point at 20.25, and then 0.50, 0.7, or at 1, and then 1.25. And how it changed compared to the actual fractals. And I'll move out and show you that again. So in my experiment, the hypothesis being, well, inserting different variable values in equations changed the outcome of fractals compared to those without the change. Actually, it did. And so when I think about how I'm scared of tornadoes and thunderstorms and how meteorologists use fractals, I think about how they can take any variable, for example humidity, and see how humidity is going to change the thunderstorm. So let's say that my variable that I changed, like this was my thunderstorm, and then I changed the variable each time, which we're going to say is humidity, and I increased the humidity by 25%. This would be how the thunderstorm would change, how it would look whenever it changed. I also was researching other fractals in nature. For example, you have the Koch snowflake, and I did a couple of different pictures of this. This is how it starts off, and it goes all the way down, and this is how it would not necessarily stop there, it would keep going, but it gets so small that you can hardly tell. Other examples are plants, like the leaves in the fern, or the veins in a leaf. And here's the demonstration of that and how it works. I've got one, and then it goes bigger, or the smaller and smaller and smaller, until you see that looks very similar to our fern. I also have in my little display some flowers, and I have peacock feathers in my little flowers, which I'll show you how those are like animal fractals. And you see, I'll show you, this is the computer generated view of the peacock feathers. And then also we have viruses. Viruses are also fractals, and how they mutate also is similar to fractals. If you can see, this is the HIV virus. And if you look really close at the triangles that make up the virus, it's similar to my little triangle straw virus. This is influenza, which is also a fractal virus. And then I have this is similar, this would be like a 3D version of the Koch snowflake, and you would just have more triangles, pyramids coming out of each side, and they would get smaller and smaller and smaller as they kept going. So overall, fractals are everywhere in nature, are all over the place, and this demonstrates how fractals change based on changing the variables in the equation for the fractal.